Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have another hard today. We have like back to back hard. If you don't count yesterday, I actually didn't post yesterday because I did the question a long time ago, so it wouldn't be a new question anymore. So I think it kind of defeats the purpose. But yeah, so let's get started for today's question. So it's called put marbles in bags. We have weight and k. So the weights would be like a list of integers. K would be like some integer. So weight is going to be 100,000. Each of the elements are basically just an int. And also k is like some number in between like 1 to like however weights we have in the list. So you have k bags, and you're also given like the array weights, weights I, right, and that denotes the ith marble's weight. So we want to divide the marbles into k bags according to like some rules. So none of the bag can be empty, and if the ith marble and the jth marble are in the bag, then all marbles with an index between the ith and jth indices should also be in the same bag. Right, so I think we are choosing some range here. Sorry, I think we are choosing some range here. If a bag consists of all the marbles, so if it consists like all the marbles from in a range, then the cost of the bag is going to be weights I plus weights j. So I think we want to minimize, right? Oh, we want to find the difference between the maximum and minimum scores. Okay. So basically we want to partition weights into into k partitions, right? Where we want to either achieve the maximum or the minimum score. So yeah, and then like we want to find the difference between that. So if k is 2 here, we can break it. Well, we can break it into like 1 and then 3, 5, 1. So that gives the minimum score. 1, 3, and 5, 1 gives like the maximum score. That makes sense because like you're making use of the larger middle numbers. Right, for this. Yeah. So, well, k is 2. That means like we can only split it in one way, and so that means the maximum and minimum scores are the same. Yeah. So, like there isn't an obvious solution to this, so we do have to play around with like some like with what we have like as examples. So yeah. So we have so 1, 3, 5, 1. Well, one thing is, maybe we can use DP. Maybe. I'm actually not sure if it will work though. Like obviously you can't try every single combination. That will be like extremely slow, and also our algo has to be n log n or faster. Like based on the bounds. Yeah. So, how do we approach this? So first thing to notice is if we have two, so let's say like k is equal to 2, right? Then like we definitely have to like the first partition has to start on the first element, and the last partition has to end on the last element. But does that help though? So like technically we just want to find, I guess like it's also good to notice that like wherever you're making a break, those are the numbers that you're adding like to the maximal or the minimal score. So it makes sense that you want to break here like for the maximal score, and you want to break elsewhere. So you want to break here for the minimum score. You don't even want to break here because like this is going to add 5 and 1, right? This is only going to add 1 and 3. So I guess we can use this breaking method. And well, because the front and end are already included, right? So that means so that means we just have to find like all the cuts that are the best, I think. So that's actually kind of just greedy, right? Unless I'm missing something, cause like this question is hard. That's why I'm like surely it is not just finding the bricks, right? Um, yeah. Are there any other conditions? I don't think so, right? Yeah, I'm pretty sure we're just breaking it like that. Um, yeah. Well, wait. Why is this the hard then? Surely there's a catch. Um, hmm. Yeah. So like, what we can do is, like, we can just find all the sums like for the breaks. We can sort it, and then like we can just like, because if we want to break it out into like k partitions, we need to cut k minus 1 times, right? So we just get the k minus 1 largest element and the k minus 1 smallest elements, and then like we can just find the difference, right? So yeah, why don't we just code that out? Right. So we want to find the, I guess, like the cut cost. So like, remember, whenever we are cutting somewhere, wait, actually, let me, because I'm so confused because this is a hard, it shouldn't be that straightforward. So I'm just gonna make sure I'm interpreting the question correctly. So yeah, so if k is 2, we have to find a break, and yeah, so we are summing, like if I and j are equal, we just like, we still have to add those like two together. Yeah, so it totally makes sense to do this. Huh. But what is the acceptance rate? It's very high as well, though. Yeah, I'm not sure why this is a hard. Well, unless I'm missing something, obviously. But let's just code it out for now. So we have an array of cut cost. So now for I in range. So we want to look at every adjacent pair, right? So length of weights, minus 1. So that's going to give us all the pairs if we just do I plus 1 and I. So something like this, right? Right, so what we want to do is we want the weights of I plus 1 and the weights of I. And when we sum that up, we can find out the... Yeah, we can find out, like, if we do a cut here, like what is the weights that we are adding in. So that's what we can do. And then cut cost, we just want to append that. Oops. Yeah, and then we just want to sort cut cost. So after we have sorted, we just want to find the sum, like for the two ends, basically. So so the minimum sum is going to be, I think we can just do list slicing, right? So it will be the sum of cut cost. So we want to go from so if we have to cut k times, we want to go up to k minus 1, right? So this makes sense. And then yeah, I low-key don't want to work out the arithmetic for maximum sum, so I'm just going to do something not efficient just by just reversing this, and then so that's going to give us the largest like k minus 1 elements. And yeah, I think that should solve the problem, right? Well, actually, we can just do this minus that. Yeah, surely there's a catch for this question. Well, does this shout hard? It doesn't, right? Okay. What is the error here? So return the sum. I'm messing up somewhere. Reversed. Wait, is this not how you do it? It's not subscriptable. Oh, I've turned it back into a list. Of course, of course. And this creates a new list, so we are not affecting the cut cost, like the actual cut cost. Yeah, let's see what is the catch here from the... What? Huh? What? I'm actually so confused now. What? Wait, let me read the comments. Like, surely people are saying that this should be easy, right? Unintuitive. Huh? What? I wonder how did the problem setter get the intuition. Yeah, I'm not sure. Wait, am I even doing it in the... Yeah, I'm doing it in like the intended way, right? Yeah, just add that and then yeah. Right, now I'm just really confused. Cause what? Yeah, or maybe I got lucky with the intuition for this question, but yeah, I don't think this one should be a hard. This one should be a medium. But I guess like my first thought is DP as well, but then like when I actually like draw out the stuff, I realized that we don't actually need to even use DP. But yeah, kind of a undeserved hard question. But yeah, well, thanks for watching, and I'll see you tomorrow. Bye.